Hey everyone, and welcome to another video. Welcome back to Ethical Explorers, the channel where we dive deep into the tools, techniques, and mindsets required to navigate the complex world of cybersecurity safely, legally, and responsibly. Today, we are taking a comprehensive look at a classic and highly effective tool included in the Kali Linux penetration testing distribution, known as DirBuster. If you're getting into penetration testing, bug bounty hunting, or web application security assessments, understanding how to map out a target's attack surface is absolutely critical to your success. You cannot secure or exploit what you do not know exists, and that is exactly where DirBuster shines as a premier web server directory brute forcer. What exactly is DirBuster? At its core, DirBuster is a multi-threaded Java application designed specifically to brute force directories and file names on web and application servers. Now, you might be wondering why this kind of aggressive discovery is even necessary in the first place. Often when you navigate to a web application through your browser, you only see the public-facing pages that the developers have deliberately linked together via the site navigation. But beneath that visible surface, what looks like a standard web server or a clean default installation is actually quite complex and messy. It often has hidden administrative panels, leftover backup files, deprecated versions of an API, configuration files containing sensitive credentials, or internal applications tucked away in directories that are simply not linked anywhere on the main site. If an attacker discovers these hidden paths, it could lead to unauthorized access, massive information disclosure, or even full system compromise. Our job as ethical hackers is to proactively find these hidden paths before the malicious actors do. DirBuster attempts to find these hidden files and directories by systematically requesting them thousands of times a minute and meticulously analyzing the server's HTTP responses. However, it is a known fact in the cybersecurity industry that tools of this nature are generally only as good as the directory and file lists they come bundled with. If your word list is outdated, small, or strictly based on theoretical dictionary words, you are going to miss a massive amount of modern developer naming conventions. A fundamentally different and innovative approach was taken by the creators of DirBuster when generating their specific word lists. Instead of just guessing what developers might name their folders, the lists were generated from scratch by actively crawling the actual internet and collecting the literal directory and file names that are being used by developers in the real world. This means the lists are highly optimized for reality, not just theory. They include the typos, the strange abbreviations, and the common project naming structures that humans actually use when building web infrastructure. DirBuster comes with a total of 9 different lists, categorizing them by size and case sensitivity. This real-world approach makes DirBuster extremely effective at finding those hidden files and directories that other basic scanners might completely overlook. And if those 9 highly optimized word lists are still not enough to find what you are looking for, DirBuster also features the option to perform a pure brute force attack. This means instead of relying on a pre-written list of words, the application can generate combinations of characters mathematically. You can tell it to try every single combination of letters and numbers from 1 character long all the way up to 10 characters long. While this approach takes significantly more computational power and time, it leaves the hidden directories and files absolutely nowhere to hide. If a developer named a secret backup file with a completely random string of 7 characters, the dictionary list would never catch it, but the pure brute force engine eventually will. Now, let us talk about how to actually operate this powerful tool. DirBuster can be run via its built-in graphical user interface, but for automation, speed, and efficiency, many security professionals prefer utilizing the command line interface. When you open up your Kali Linux terminal, you can pull up the help menu by simply typing DirBuster followed by a space and a -H. This instantly displays the usage syntax and the various operational flags you can pass to the tool. The base command structure is generally java-jar DirBuster followed by the version number, or simply typing the word DirBuster followed by -u and the specific target URL you are authorized to test. Let's break down the crucial options you'll use on a day-to-day basis. The -H flag is used to start DirBuster in headless mode. This means no graphical user interface window will spawn on your screen, which is incredibly useful for running the tool on a remote virtual private server. When running in headless mode, the final report will be automatically saved upon exit. Next is the -L flag, which allows you to specify the exact word list you want to use. By default, Kali provides the directory list 2.3 small text file. The -G flag tells DirBuster to strictly only use GET requests. This consumes slightly more bandwidth but can sometimes bypass poorly configured firewalls that block standard head requests. The -E flag is an incredibly important feature. It allows you to specify a comma-separated list of file extensions you want the tool to automatically append to the word list entries. For example, passing PHP, text, and zip helps uncover sensitive backend files. Then we have the -T flag, which dictates the number of connection threads. The default setting is 10. This parameter controls the speed and aggressiveness of your scan. Managing your thread count based on the target's capacity is a vital skill to avoid accidentally causing a denial of service condition. The -S flag sets the start point of the scan. By default, it begins at the root directory, but you can target specific folders. The -V flag activates verbose output, giving you a detailed stream of information in your terminal. The -P flag instructs DirBuster to not parse HTML, speeding up the scan by ignoring internal links. The -R flag stops the tool from behaving recursively, preventing it from diving into newly discovered directories. Finally, the -r flag allows you to explicitly specify exactly where you want the final text report saved. So, how do we put all of this theoretical knowledge together into a practical, ethical context? Let's take HackerOne.com as our target showcase for this conceptual demonstration. HackerOne maintains a public bug bounty program, meaning independent security researchers are actively authorized to test their infrastructure for vulnerabilities, provided they strictly follow the rules of engagement. If we were preparing to run a directory brute force assessment against HackerOne.com, we would open our terminal and carefully construct our attack command. Our command would look exactly like this: DirBuster -u https://www.hackerone.com -hif-t20-l/directory-list/DirBuster/directory-list-2.3-medium.txt-e, PHP, TXT, BAK-R. Let's review exactly what this specific command is doing to HackerOne.com. We start with DirBuster -u pointing to the target URL. We use -H to run it entirely in the terminal without popping open a graphical window. We set -T to 20 threads, which is a moderate, responsible speed that won't overwhelm HackerOne's robust servers. We use -L to specify the medium-sized DirBuster word list for a thorough but time-efficient scan. We employ -E to explicitly hunt for PHP files, text files, and backup files ending in .bak. Finally, we append the -R flag so the scan stays on the surface level and doesn't recursively dive down a rabbit hole, which could take days to complete. As the application begins its work, it will systematically shoot hundreds of HTTP requests at HackerOne.com. The vast majority will hit dead ends and return a 404 not found HTTP status code, which DirBuster intelligently ignores. But occasionally, the server will respond differently. It might return a 200 OK, meaning a file was successfully found and is accessible. Most interestingly, it might return a 403 forbidden. A 403 generally means that a specific directory exists on the server, but you don't have the proper privileges to view it. In an ethical hacking engagement, a hidden 403 directory immediately becomes a high-priority area for further highly targeted manual testing. Using a tool like DirBuster is an essential step in mapping out the underlying server structure and uncovering hidden attack surfaces. However, you must always remember that the power of this tool comes with strict operational responsibility. As members of the Ethical Explorers community, we only point these aggressive discovery tools at targets that we explicitly own or where we have undeniable legal authorization, such as a formal corporate contract or a public bug bounty program like HackerOne. Never point DirBuster at random websites without permission. Keep learning, keep exploring, but always keep your actions ethical. Thank you for tuning in to this deep dive. Stay safe out there in the digital landscape, and I'll see you all in the next exploration.